You are watching video on SEE Class 10 Subject Science. In this video series, we are going to have complete explanation of the chapters. This video deals with Physics chapter Pressure, and this is part 1 of the chapter. Now, pressure, we know the definition of pressure. Pressure is force acting on unit area. When force acts on unit area, pressure is applied. Force is measured in Newton and area is measured in meter square. So SI unit of pressure is Newton per meter square. It is also called Pascal. Newton per meter square. It is also called Pascal, SI unit of pressure. Now here we are dealing with liquid pressure. Liquid pressure is pressure given by liquid. And liquid pressure is expressed by formula P equal to dHg. Now we will see how this formula is derived here. Okay, so we are dealing with liquid pressure. That is why you should have liquid in a vessel or water in a beaker, and you need to know density of water here. You need density of water, cross-sectional area of the beaker, and height of the liquid column or depth of the liquid column. So you need these three to derive formula P equal to dHg. Density of liquid, cross-sectional area of the beaker, and height of liquid column. So here density of liquid is D in a beaker, cross-sectional area of the beaker is A, and HB the height of liquid column. Now from definition of pressure, we know the definition of pressure. Pressure is force acting on unit area, P equal to F by A. So from here P equal to F divided by A. Now further P equal to F can be written as M into G, because force equal to M into G or weight equal to M into G. So here weight is equal to force. Okay, so this way we can write F equal to M into G, and further P equal to mass can be written as density into volume. Density into volume into G divided by A, because density means mass per unit volume. From the definition of density, density is equal to mass per unit volume. So mass can be written as D into V. So this way mass can be written as D into V. So further solution we can see here P equal to D, and B can be written as area into height into G divided by A, because volume equal to area into height. Okay, volume equal to length into breadth into height. Length into breadth is area and into height is volume. So volume can be written as A into H, area into height. Okay, so here in this area can be cancelled out. So the remaining you will have is dHg. So liquid pressure can be derived in this way, P equal to dHg. So here P is equal to liquid pressure, D is density of the liquid or water if you have taken water in the beaker, H is equal to height of liquid column or depth of liquid column, and G means acceleration due to gravity. So density of the liquid, height of liquid column, and acceleration due to gravity. Now in this formula, density of the liquid and value of acceleration due to gravity at a particular place remains constant. These two are constant. The only variable factor is here height of the liquid column. That is why liquid pressure is directly proportional to height of liquid column or depth of liquid column. That means if height of the liquid column is more, pressure will be more. If height of the liquid column is less, pressure will be less. So this is liquid pressure. Now we were discussing about unit of pressure. SI unit of pressure is Newton per meter square or Pascal. So another unit of pressure is millimeter of mercury. Liquid pressure can be expressed as millimeter of mercury. Millimeter of Hg means millimeter of mercury. So here 760 millimeter of mercury column is equal to 1 atmospheric pressure. It is also called atmospheric pressure, millimeter of Ag or atmospheric pressure. So this means if you have 760 millimeter long glass tube filled with mercury, then pressure given by this mercury at the bottom is equal to 1 atmospheric pressure, which is almost equal to 10 to the power 5 Pascal. Almost 10 to the power 5 Pascal is equal to 1 atmospheric pressure. Now the next part we are going to see is Pascal's law. This is the law related with liquid pressure, and this law was given by Blaise Pascal, French physicist, in 1647 AD. Now this law can be stated this way: when pressure is applied on a liquid enclosed in a vessel, it is transmitted equally in all the directions. So there is a liquid in a vessel, the pressure is applied at one point of the vessel, then this pressure will be distributed to all the parts equally. So this is the law. The pressure acts at right angles to the surface of the vessel exposed to the liquid. Pressure is always acting at the right angle to the surface of the vessel. Okay, so when pressure is applied on a liquid enclosed in a vessel, it is transmitted equally in all the directions. So Pascal's law can be stated in this manner. Now experimental verification of Pascal's law. How can you verify it experimentally? So this is very simple. You should have a vessel filled with water or any liquid, and you have to apply pressure at one point. That pressure will be carried to all parts equally, and pressure will be acting at right angle to the surface of the vessel. Okay, so let a vessel filled with water, this is the vessel filled with water, and PQRS are the pistons fitted with same area A. So there are pistons to apply pressure. There should be points to apply pressure. So these are the pistons from where we apply pressure. Okay, PQRS are the names of the pistons, and all these pistons have same area. Area A, area A, area A, area A. These areas are equal. Okay, means all these pistons are of same size. Now in piston P, force P is exerted on area A. So in this piston P, you have applied force on this area. Okay, you can apply a force in any one of these pistons. Okay, any one. So force is applied on one of the pistons on area A. So in this case pressure will be produced. Okay, at this point pressure at this piston pressure is produced. This pressure is carried to other parts of the liquid equally. Means to other pistons this pressure is carried to other pistons equally. No, so pressure 1, pressure 2, pressure 3, pressure 4, all these are equal, and this pressure is acting on this piston, this piston, this piston. Okay, so this pressure P1 is transmitted to all the pistons equally. That means P1 is equal to P2 equal to P3 equal to P4. Okay, now P2, P3, P4 pistons come out equally because this piston is pushed inward, and because of this pressure other pistons will come out equally. Okay, and that is again equal to this one first piston P1. Okay, whatever is the length of this piston coming inside, there should be same length of other pistons going outward. Okay, so same length means same pressure. So this way Pascal's law is also known as principle of transmission of liquid pressure. So Pascal's law is known as principle of transmission of liquid pressure. Liquid pressure is being transmitted, being transferred to all the parts of the liquid equally. So principle of transmission of liquid pressure, and the pressure is acting at right angles to the surface of the vessel. Pressure is acting at the right angles to the surface of the vessel. This is Pascal's law. This is the experimental verification of Pascal's law. This is very simple. You have to take a vessel. In this vessel 4 pistons are fitted, and you are going to apply force on one piston. This force acting on area will produce pressure. This pressure is carried to other pistons equally. Okay, and because of this other pistons come out at the equal length. Okay, so this shows pressure is same, the same amount of pressure has been exerted on all the pistons. So application of Pascal's law. What is the use of Pascal's law application? uh, Pascal's law is used in all types of hydraulic machines, all type of hydraulic machines. And hydraulic machines are hydraulic press, hydraulic brake, hydraulic garage lift, hydraulic crane. These are the different types of hydraulic machines. Now we are going to see the next part, principle of hydraulic machine. So hydraulic machines are hydraulic press. Okay, pressing, like cotton bundles are pressed. Hydraulic garage lift, to lift up the vehicles for cleaning purpose or for repairing purpose. Hydraulic brake in the vehicles, four-wheelers, hydraulic brake is used. And hydraulic cranes which are used to lift up heavy loads. Okay, now these are the pictures. This is hydraulic lift and this is hydraulic brake, and this picture is of hydraulic press. Okay, now principle of hydraulic machines. How does a hydraulic machine work? That is principle. So first of all, you need to know the construction. Construction is very simple. You need to have two tubes, cylindrical tubes, and these two tubes, one is smaller and other one is bigger. A smaller tube has cross-sectional area A1. This is a smaller one, A1. A2 is bigger one, bigger cylinder. Okay, now these two tubes or the cylindrical tubes are connected by tube T. These are interconnected by tube T. Okay, now these two cylindrical tubes are filled with water and the pistons are fitted in them. Okay, A1 has piston P1, A2 has piston P2. Okay, and on P2 load can be lifted up. The work need to be done is over here, and from P1 we apply force. Okay, it is easier to apply force on a smaller area. That is why a small piston force is applied. Okay, now the construction, two cylindrical tubes are connected with the tube T. The cross-sectional area of a small tube is A1 and big tube is A2. Two pistons P1 and P2 are fitted in the tubes and these tubes are filled with water. We are dealing with liquid pressure, that is why there should be water or any liquid. Now the working of this hydraulic machine, how does it work? Force is applied on the piston P1 on the area A1. So on piston P1 force is applied. Okay, force is applied on piston P1. So for F1 is applied on A1. So the pressure is produced. Okay, this is equation number 1. Now according to Pascal's law, this pressure is transmitted to this piston P2. The same pressure goes to P2. So on P2 pressure is applied on P2 and P2 already has A2 surface area. That means F2 has been exerted on P2. Force is acting on this area and that is why P2 is produced, pressure is produced, and P2 is equal to P1. Okay, let this be equation number 2. Now according to Pascal's law, P1 is equal to P2. Okay, so here P1 is equal to F1 divided by A1 and P2 is equal to F2 divided by A2. Now rearranging the equation, what can you find this cross multiplication? A2 goes this side, A1 goes this side. Okay, so A2 divided by A1 is equal to A2 divided by A1 is equal to F2 divided by F1. F2 divided by F1. If F1 comes here. Okay, F2 divided by F1. So this way A2 divided by A1 is equal to F2 divided by F1. Let this be equation number 3. And this is the principle of hydraulic machine. So this means you see here A2 is bigger than A1. A2 is bigger than A1 because we know it from construction only. No, here in making this one in the construction, it is said clearly A2 is bigger than A1. So A2 is bigger than A1, right? If A2 is bigger than A1, then F2 must be bigger than F1. Okay, F2 must be bigger than F1, because from this equation A2 divided by A1 should be equal to F2 divided by F1. Ratio of these two should be equal to ratio of these two. Supposing A2 divided by A1 equal to F2 divided by F1, right? Supposing A2 is 4 and A1 is 2, right? Then 2 ones are 2, 2 twos are 4, here is 2. Okay, that the here should be, if it is 2, then this side also should be 2. Okay, in order to make it 2, F1 should be, supposing let it be 2 and F2 is 4. 2 ones are 2, 2 twos are 4. So this way 2 equal to 2. Okay, or in place of 4 by 2 you can write it this way also. 6 divided by 3. 3 ones are 3, 3 twos are 6, or 8 divided by 4, 4 ones are 4, 4 twos are 8, or 10 divided by 5, 5 ones are 5, 5 twos are 10. In every case you are getting 2, 2. Okay, and this 2 is equal to this 2. That means you see F2 is always bigger than F1 in this fractions, no? Yes, F2 is 4 over here and F1 is 2. Okay, and F2 is 6 and F1 is 3. So anyway, F2 must be bigger than F1 in order to be equal to this one. This ratio should be equal to this one. Okay, that is why if A2 is bigger than A1, then F2 must be bigger than F1. Okay, this is the principle of hydraulic machine. So we know A2 is bigger than A1. Okay, and we have applied force F1 on a smaller piston, which is much easier to apply force because it is in a small area. Okay, F2 has been applied by you. Okay, but this F2 has been produced by hydraulic machine itself. Okay, while carrying pressure P2 in piston 2. Okay, F2 divided by A2. So A2 is already there, and this F2 has been exerted on piston 2. Okay, so that P2 is produced. Okay, so this force has been increased by hydraulic machine itself automatically. Okay, that is why hydraulic machine is also called force multiplier, because you have applied F1 pressure and the machine has multiplied it automatically F2. Okay, you have applied 2 Newton force and machine has made it 4 Newton force. Okay, so that P1 becomes equal to P2 according to Pascal's law. Okay, so hydraulic machine is a force multiplier. Hydraulic machine is a force multiplier. Okay, now we'll see the summary of principle of hydraulic machine. How can you sum up the principle of hydraulic machine? It is like this: liquid cannot be compressed. Okay, and pressure applied on liquid of vessel is transmitted equally. Okay, Pascal's law, and ratio of A2 divided by A1 should be equal to ratio of F2 divided by F1. Here F2 is load and F1 is effort. Yes, this is F1 is force input and F2 is force output. Yes, and A2 divided by A1 is A2 is area of big cylinder and A1 is area of a small cylinder. Okay, so the principle of hydraulic machine can be summed up in this way: liquid cannot be compressed, pressure applied on liquid of vessel is transmitted equally, and A2 divided by A1 must be equal to F2 divided by A1.